Okay, Beta. So state the difference between scalar quantity and the vector. So scalar has magnitude and unit. Vector physical quantity has magnitude, unit, and most important, direction. So this is the difference between scalar and the vector. So the difference is of only direction. Next, state two examples of each type of the quantity: scalar, speed, as like this, and the vector, displacement, velocity, acceleration, momentum, etc. And the next part is figure 1.1 shows the direction and the size of the two vectors P and Q. In the space next to the figure 1.1, draw a labeled vector diagram to show the resultant vector obtained by adding the vector P to vector Q. Draw the vector P and Q and the resultant vector to the same scale as this. Okay. So we have to draw both. So first we will draw this P, same length. First measure the length of the P with the scale and draw this new vector. It is directed in this direction. Then by joining the head of the P with the tail of the first, so this is the tail, it means we will draw this vector Q here. So this is called head to tail, head of the first with the tail of the second. So its head is this is the tail. And then you have to draw the resultant. Resultant is actually joining the tail of the first with the head of the last. So this line with the scale, this is the resultant vector. So we have to draw only, no calculation. So this is question number 1 and total marks 5. Look at again, 1 mark for this, 2 marks for this, and then 2 marks for the drawing. But you have to draw according to the scale, according to the length, same length. Now move to next question. And the car approaches a set of the traffic lights. The light changes to red at the time 0. This is the time at which it goes red. So this is the time. Figure 2.1 shows how the speed of the car changes with time. The car starts to slow down a short distance, short time after the light changes to red. So after this time, it slows down, meaning the brakes are applied. Determine the time between the light changing to red and the car starting to slow down. So this time is required. So mark it at the x-axis. This is 1, this is 1.2, this is 1.4. So we will write here 1.4 second is the time and at which it starts slowing down. Next is what is meant by uniform acceleration. Look, acceleration is equal to change in velocity divided by time. We have to write what is meant by uniform acceleration. If change is in velocity, or each interval of time one second is same. In every second, the velocity is changing with the same amount. In every second, suppose 5 meters per second, next second 5 meters per second, then this is called uniform acceleration. Mean the same time and same change of velocity. Per unit time, mean that in each interval of time, suppose 1 second, the change of the velocity is same. Then the acceleration is uniform. So suppose This is time. This is velocity. If the straight line, this is called uniform acceleration because after 1 second, if the velocity is 3, after 2 seconds, it will be 6. So in first second, 3 change, second, 3 more, then 3 more. So this is called the uniform acceleration. Next, state how the figure 2.1 shows that the deceleration of the car between 2 second and 7 second is non-uniform. At 2, look at the gradient of the graph. And at the 7, the gradients, look, this line is more steep and this line is less steep. So we will write here, gradient of line at 2 seconds is more steep as compared to time 7 seconds. This is the reason it is not uniform. Next, determine. Okay, next, determine the distance of the car travels from movement of the car starts to slow down until stops. Determine the distance the car travels from the moment the car starts to slow down and to stop. So this is the time at which it starts slowing down and this is the stop. Mean this area is required. So we will divide it in 2 parts. This area is trapezium and this area is triangle. So first area of the trapezium, the area of the trapezium is 1 by 2, sum of parallel side into height, 1 by 2. This side is 20 and this side parallel is 8. So 20 plus 8 multiplied by the distance between the height between 2 parallel sides. So this is the height, mean it is 4 minus 1.4. So it's 2.6. So multiply by 2.6. So we will calculate the area of this trapezium first. And the next, we have to calculate the area of the triangle. And the area of the triangle, 1 by 2, base into height. So look, this is the base from 4 to 7, this is 3. And the height is 8. The 2 ones are 2 fours are, so this becomes 12. And then you have to calculate this. This is 28, means 14 times 2.6. Now, the total answer of both this and this, it is becoming 48. Multiply these two and then add this. So this is coming 48. So we will write each and everything here. So the all calculation over here, and this is coming 48. Now, look at the triangle again. Trapezium, triangle, area of the trapezium, area of the triangle, then both answers are added. And the sum of these two answers is coming 48. Next, question number 3. Figure 3.1 shows a small brick hanging from the Newton meter. The reading on the Newton meter is 3 Newton. Describe how the reading, the Newton meter. Look, this Newton meter measures weight. Weight is equal to mg. Describe how the reading on the Newton meter is used to find the mass of the brick. So the mass of the brick is equal to weight divided by g. So the weight divided by 9.81. No need to calculate the answer. We have to just inform about the method. So weight divided by the value of g is the mass. Next, the same brick and the Newton meter are used in the apparatus. The meter rule is pivoted at its center and is balanced. The reading on the Newton meter is not shown. So this is pivoted at the center. So weight of the scale, weight of the meter rule is acting at this point. Now the question is, state the principle of moment for the equilibrium. So principle of moment. First we have to write in the state of equilibrium. Sum of clockwise moments exactly equal to sum of anti-clockwise moments. This is answer. Sometimes we miss this portion, this one. So this is very important. Otherwise, no mark. If we simply write sum of the clockwise moment is equal to sum of no mark, correct. So do mention this, the state of the equilibrium, otherwise no mark. And the next, determine the reading on the Newton meter. So look at this. It is pivoted here. Weight is acting at the pivot. So weight has no turning effect. So the force which is exerted at the pivot, which passes through the pivot, has no torque. So the weight of the rod is exerted at the pivot. It has no torque. So this hanging mass is trying to rotate anti-clockwise about this pivot. And this Newton meter is exerting force in this direction for the clockwise moment. Look, it is at rest. So sum of clockwise moment is equal to sum of anti-clockwise moment. So the force exerted by the Newton meter is required, and the distance of this from the pivot is 20, but we have to convert this in meters. And the second, look, this weight, the reading on the Newton meter, this the weight of this block, this brick is already given here, 3 Newton. So we will write here 3 multiplied by, and its distance from the pivot total 10 plus 20, it's 30. So 30 divided by 100, 100 cancel. So this force multiplied by 20 is equal to 90, and F is equal to 90 divided by 20. So the answer is 4.5 Newton, but you have to write each and everything over here. So the reading is 4.5 Newton. This is the reading on the Newton meter. So look at the answer. F1 D1 is equal to F2 D2. F1 multiplied by its perpendicular distance 20, but in centimeters, so you have to show the working for the meter conversion. And then the brick weight is 3 given multiplied by 30 divided by 100 because the total distance from the pivot. Next, a beaker of the water is placed so that the brick is partially submerged in the water as shown in the figure. The apparatus is adjusted to keep the rule horizontal. Okay. Suggest why the reading on the Newton meter is less than the answer. Look, this water is exerting force upward, which is called the thrust. Do remember, we have done in the class that the thrust is a force which is exerted due to pressure difference, and it is calculated by this formula: pressure difference at the bottom and top multiplied by area. So look, when this block is lifted up with some force, when force is small, then the turning effect is small. So definitely the other side, the force will be small. Reason, F1 D1 is equal to F2 D2. When this big force is small, distances are same 10, 20, then definitely the Newton meter will exert less force because the weight of the brick decreases due to thrust of the air. This water is exerting force upward, so the load becomes less. So definitely in water, the weight becomes less. So due to the upthrust, we will write here, due to upthrust of water, brick weight decreases, hence moment decreases. So less force is exerted on the meter. Next, look at the question number 4. This is about the light. In a demonstration, a teacher uses a loud ticking clock, two hollow tube A and B, a barrier and a smooth surface. The clock is used as a source of sound. Figure shows tube A and a clock, the both fixed in the position on the left of the barrier. Sound from the ticker clock passes along the tube A and inside the smooth surface. A student listen to the sound passing along the tube B, which is on the right of the barrier. Draw the tube B in the position where the sound heard by the student is loud, okay? So we will draw this. So this is the sound emerging from the tube A, this angle of incidence. So same angle of reflection. So this is angle of reflection, both angles are equal. So this tube B must be placed along this line to hear the clear sound. So this is the position. So the position of this tube is this, because the angle of incident and the angle of reflection both must be equal. Next, explain your answer. So in reflection, angle of incidence is equal to angle of reflection plus position of tube B is adjusted at angle equal to reflection. Next, the speed of the sound in the air is 330. State the typical value of the sound in solid. We have done the class. So it is approximately 3000 meter per second. In liquids, it's 1200 to 1500. Solids, minimum 3000. It can be more than 3000. So you have to remember these values. Next question. It's about the static electricity. We started this chapter last week. So figure shows a method of producing sandpaper using static electricity. Glue is sprayed on the moving paper. The sticky paper then passes between the two metal plates. One of the plate is positive, another plate is negative. So this plate is negative, this plate is positive in polarity, as mentioned. There's an electric field between the plates. Yes, we have done in the class like this, the electric field between two plates. Okay. Draw the electric field lines between the two plates, show the direction of the electric field. So here, this is negative, this is positive. So electric field is directed from positive to negative. Inside, uniform field, so equally spaced. And outside, you have to draw a curved field. We have done this in the past. So this is the shape of the electric field. Next, grains of the sand are present just below the sticky paper. Each grain of the sand is a conductor of the electricity. Figure 5.1 shows two layers of the sand grain in the space between two plates. So look at the sticky paper. These are the grains of the sand. Explain using the idea about the movement of the charges why the top layer of the sand becomes positively charged. So this is becoming positively charged. So positive charge we have done is the vacancy of electron. So electrons are shifted to these positive plate, leaving behind the vacancy, so negatively charged. So electrons from sand are attracted and then shifted towards the positive plate, thus positive charge at sand. So these electrons are shifted to this positive plate, they are attracted. So the vacancy of the electron created, so the electron is producing the vacancy of the charge, which is a positive charge. State why the top layer of the sand moves towards the sticky paper. Look, this is negatively charged because it's connected to the negative. So there is a force of attraction between negative and positive. So this sand is attracted by the sticky paper. So we will write here, force of attraction between positive sand and negative top plate positives. There is a force of attraction between the positive sand and the negative top plate, so they are attracted. Next, a student receives an electric shock by walking across a certain type of the carpet and then near touching the piece of the earth metal which with his hand. The potential difference between the hands of the metal is 2000 volt and the charge transferred is 4 into 10 power minus 4. Calculate the energy transferred when the spark jumps across the air from this. So look, do remember Q is equal to IT. This is the first formula. Q is equal to number of electron multiplied by charge of electron. And next, energy is equal to charge multiplied by voltage. So these are very, very important formula. So we will write this one. Energy is equal to charge multiplied by voltage. The charge is 4 into 10 power minus 4. And this voltage is 2000. So when it is multiplied, the answer is 0.8. But we will write here 0.80 energy in joule. So look at the answer. This is the electric field between positive and negative plate. And these are actually the charges. Electrons are transferred by the attraction, creating the positive charge. And there is attraction between the positive sand and the negative sticky paper. And then energy is equal to charge multiplied by voltage. So energy is equal to charge multiplied by voltage. Next, the power input to the filament when connected to a 12-volt supply is 20 watts. State what is meant by power. Look, power is equal to work divided by time. It's energy divided by time. So we can write rate of work is called power. How you can write work done per unit charge work done per unit charge, work done per unit time is called power. Either this. Next, calculate the current in the filament. The power given, voltage given, and there is a formula, power is equal to IV. So power is 20, current required, voltage is 12. So current is equal to 20 divided by 12. So 20 divided by 12 is 1.7 ampere. And the resistance of the filament, look, V is equal to IR and R is equal to V over I. Voltage is 20. Voltage is, just a minute, voltage is 12, not 20. Divided by 1.7. So it is approximately 7. So the answer is 7, approximately 7.0 ohm. Next. The filament in another lamp is made from the thinner wire of the same length and made from the same material. Look, resistance is inversely proportional to area. Thin wire has more resistance. So due to this small area, the resistance increases, then the current decreases. According to the formula, power is equal to IV. When voltage is same, then the power directly proportional to I. When the current decreases, power also decreases. So we will write here, resistance is inversely proportional to area. Thin wire has small area, so large resistance. When the resistance is large, the current will be small, and the power IV, voltage supplied same, so power directly proportional to I, hence power decreases. Figure 9.1 represents the conversion of energy in a mobile phone. State the form of the energy stored in the battery, definitely chemical energy. State the useful form of the output energy from the battery, definitely electric energy. State two useful form of the output energy from the cell phone, definitely we enjoy sound and pictures mean light and sound. When the battery is in the use, the average current is 1.3. Determine the charge in 2 minutes. So we have done that Q is equal to IP. I current is 1.3 into milli. Milli mean 10 power minus 3. And the time 2 minutes, we will convert this in seconds. So 2 times 100. So the answer is coming, let me call 3 2 0. Okay. So it is 0.16 coulomb. And the next is, a student estimates the thermal energy produced in the battery when the mobile phone is used and uses this value to estimate the efficiency of the battery. He measures the temperature rises of 5 to the battery in the period of, and the battery output is 52. The mass of the battery is 110 and its specific capacity 830. Calculate the thermal energy. So temperature changing, so we will write here Q is equal to mc delta theta. The mass in kilogram will be 110 gram divided by 1000, specific capacity 830, and the change of temperature is given 5. So after calculation, it is 1150. It is 460 joule approximately. Next is, state what is meant by efficiency. So efficiency is the ratio between output energy and input energy. Ratio between output energy and input. Calculate the efficiency. So look at the diagram. This statement. Useful energy output is 52 plus this energy lost. So the input energy is actually input is equal to loss plus output. It is 460 plus 5200, and this is 5660 joule. Then efficiency, output over input. Output useful is 5200 and the input is 5600. And then after calculation, the answer is 0.92. So either write 0.92 or write just 92%. It's up to you. Next, suggest and explain one reason why the value of the efficiency is larger than the actual efficiency of the battery. So suggest and explain one reason why the value of the efficiency calculated at 3 is larger than actual. The reason is thermal energy is lost in the surrounding. So thermal energy is lost in the surrounding. And temperature of cell phone increases. Hence, energy produced larger than calculated. So we are calculating this energy and this energy, this one output. But energy which is lost in the surrounding, there is no calculation of it. That energy is not considered. So actually energy produced is large. So that's why the answer will be different. We are actually calculating the output energy as light and sound plus the temperature of the cell phone. But what about the energy which is lost in the surrounding? That's why the answer is different in actual. Now look at this. It's a wave. Figure shows two waves moving from shallow into the deep water. The wavefront shows this. The wave is made of the dipping a wooden bar up and down the water. The bar makes 100 complete down in 5 seconds. Determine the wavelength. So look, this gap is the wavelength. So these gaps are 1, 2, 3, 4. So wavelength is equal to total length divided by 4. It is 3.0 centimeter. This is the answer for the wavelength. And the next, calculate the frequency. Frequency is the number of waves divided by time. Number of waves are 10 and the time is 5. So the answer is 2 or 2.0 hertz. Determine the speed. Speed is equal to V is equal to F lambda, and F is equal to 2 and the lambda is how much? Is 3. So answer is 6.0 and centimeter per second because this 3 is in centimeter. Next, in 4, draw the line to show what happens to the wavelength frequency. It enters the deep water. Look, the frequency remains same. Frequency remains same. Wavelength increases.